Hey, and welcome to our very first tutorial of algorithms. Today I will show you how to solve the most famous question in Leetcode called to-sum. First things first, this question has been mostly asked by Amazon, but for past 6 months, according to Leetcode itself, it has been asked by various other companies like Adobe, Apple, Google, Bloomberg, Facebook, and you name it. Our primary language of choice is going to be JavaScript, but we will explore two possible solutions with map and objects. So without further ado, let's dive in. Okay, let's go through the problem first. Given an array of integers of nums and an integer target, return indices of two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So let's see some examples here. In the first example here, we have 2, 7, 11, 15 as nums array, and our target is 9. We need to find out which two numbers add up into 9. As you can see, 2 plus 7 is 9, and it will accept their respective indices. Second example here, we have 3, 2, 4, and our target is 6. If we add up 3 and 2, it's going to be 5, but if we add up 2 and 4, it will give us our target value of 6, which we are looking for. So we will return their indices, like 2 is index 1 and 4 is at index 2. Last example, we have given two trees as our nums array and the target is 6. If we add them up, we will end up in our target and we just return their indices as a result. So how we can solve this issue? As a very simple solution, what may appear in our mind first is we can easily iterate through array once, then on each index iterate through the array second time, and based on indices sum up two values and check if that adds up to the target or not. Something like the solution in here. Although this is a working solution, but the problem is that it is not efficient. The reason is we have double for loops in here. Whenever we do multiple nested loops over a set of data to do some operations on its values, it reduces the speed of our algorithm based on the size of given array. If I simplify this even more, generally in computer science, when we want to say how fast an algorithm is, we use a term called time complexity, which tells us the amount of work that takes for the computer to run our algorithm. It basically represented with O of n sign, that n shows the amount of given input's length. In our case, n refers to the length of our nums array. In this solution, we reduce the speed of our algorithm 2 times more per each value, and that is why we need to add a power of 2 in our time complexity representation. If we look a bit deeper to this solution, we would find a much more bigger problem. Basically, we always need to consider large data sets and optimize our solution based on that. Like, imagine a nums array with 1,000,000 values inside of it. Now the question is, will this O n in power of 2 solution be efficient enough, or it will use our compute resource so much? That is why we're mostly looking for more fast and O n solutions. But keep in mind that there are other time complexity benchmarks that are even more faster, like O of log n, which we will consider them when solving feature problems. In order to save some computational power, what we need to do is using a more efficient data structure called map. As you might know, map is a key value storage, but how we are going to use it? The idea is that we need to know the value that we are looking for beforehand. I know the fact that you may hate math, but we need basic math here. Let's take a look at a simple addition example. If we add two numbers together, like a plus b, it would give us c. Now the situation here is that if we iterate over our nums array, in each iteration in our loop, we already have c, which is our target, and our current value in that iteration over our nums array, which could be either of a or b in this scenario. So that being clarified, how we can leverage these two clues that we have in our hand in order to find the other missing part per each value in array. The answer is super simple. We can say that if we are looking for a, it will be equal to c minus b. Or if we are looking for b, it is going to be c minus a. But why am I telling you this? Answer is simple. The trick here is, as I said, we have two clues in our hand. One is value and other is our target value. What if we calculate the complement to the value that we have and store it in a map associated with the index that we are currently in order to check it in future? Something like this. So in next iterations, if we cannot find that value in our storage map, we have nothing to do with that. We will just keep storing values with their respective indices. But if we happen to find complements as a key in our storage, then we would know that we have stored its complement previously associated with its index that we are looking for, which is nice because at that step we have our answer. The only thing we need is grabbing the complement's value index from our map plus current loop index that we are in, then we are done. Now let's walk through an example in order to demonstrate the map solution for you. Here is the same first example that we saw earlier. So if we start to iterate over our array, in first iteration of our loop, we will not have anything in our scene map at the moment. Next step, we will calculate the complement. 9 minus 2 will give us number 7. Then we will check if we have it in our storage. Answer is no, so our check will be falsy, which will make us to store the current value and its index in our map, which is number 2 associated with index 0. Next iteration. At index 1, we calculate the complement again. Complement will give us number 2, but now look here in our map. We already have a key of 2 in our map that points to index 0, which means that previously we have found a value in our iteration that if we add it up with our current value, it will give us the target that we are looking for. So what left now is only return the indices. First grab complement's index from our map and then get current index of iteration. And finally, we have our answer. That being said, let's explain the answer and write the code for it. So here we are in Leetcode with two-sum problem to solve. What we are going to do is, first we will create our hash map, like const scene is going to be new JavaScript map. Then we will do the loop for let I equal 0, I less than nums.length, I plus plus is going to be like this. Next step is going to be calculate the complement, like const complement is going to be your target minus nums at that index. Next, we will check if our map has that complement value. If scene.has complement, at this step, this is our answer part. Like we found our answer in this step. And the only thing is that we need to return the value and the current index. Like return an array scene.get complement and or current index. Otherwise, we will store the value as key and or current index as value. Like else scene.set nums I and our current index. And this is it. This is our algorithm. So let's go through a smoke test to see if it works. Yeah, all of our test cases are passing, and if we submit it, everything works correctly. So that was a map solution, but what if your interviewer limits you to use an object as your hash map? Let's do the object solution because there's a little thing that would make it not work at the first time that you are trying it. For the object solution, we are going to do a little bit of change for the current solution. First, we need to change map implementation to an object like this. Then we will use for I loop instead of a normal loop. We need to use this in order to make it work, but I'll explain you shortly why we need this change. So we will do something like for let I in nums. Last step is going to be like we need to change things like has and get, which is JavaScript's map specific API, into object implementation. Theme is not going to be like this, it's going to be inside of bracket. Second, again like this, it's going to be inside a bracket, and in here we need to set nums.I is going to be I. Then let's go through a smoke test to see if it works. Let's hit the run button. There we go, everything works. And now, as a little bit of explanation, you might have asked that why we switched to for I loop here. For that, we need some clarification about how for I and a normal loop works in JavaScript. So let's go back to slides. So here in the left hand side, I have a normal for loop. And in the right hand side, I have a for I loop. As you can see, in both cases, I just log the index and the value at that index of my array. But here comes the big difference between these two loops. In normal loop, the type of my index is number, and the type of my value at that index is string. But in for I loop, the type of my value at iterations index is string, which is normal, but more importantly, the index type is also string, which is like the difference here. That is the big difference and has an interesting impact in end results of our algorithm. So that type difference in indices could be problematic for the keys that associated with index 0, specifically when we do the if checks. Let me show you in code. So back to the Leetcode, I'm still using an object for my storage hash map, and I've replaced my for I loop with a normal loop. Remember that normal for loop would give you the index of iteration in number format. So basically the type of I inside of this for loop is going to be number. In each iteration, I'm logging three things here. First is my complement, second is my index associated with complement, and last thing is my entire hash map. Now if we run this to see the log results, in here at first iteration we don't have any cached index, that's why its value is undefined. But the interesting thing happens after we have iterated over first index. As you can see, the cached index in second iteration is type of number. And like I said, what would happen after we pass the first iteration and then we try to check for that index with our complement? Or if check will be falsy for index 0 because it is type of number, and we would never end up inside of this code block in here in order to return our answer. The reason is that if we pass not ordinary things as a check for if, JavaScript will always be converted that to Boolean first. Then if the result of that coercion was true, say, it will continue inside of that code block, and if it not, it wouldn't. Let's try to see how our if check would be work in for I loop, because it was working correctly, and as I said earlier, iterations indexes in for I loop is in string format. Now I have switched to the for I loop, and if I run the smoke test, as you can see, just because of that little difference between a normal for loop and for I loop, the indices type will be string in this case, and the if check for getting associated indices based on complement value will no longer be falsy. So if we go back to a normal for loop solution like this, what we could do in order to make this work, easily we have two options here, I would say. Either we specifically store indices in a string format like this one, we could say string of I, and if I run this, it should work because this type is going to be string and our if check will not be falsy anymore. And option number two would be we explicitly check if there was nothing associated with complement key in our hash map, something like checking for that value not being undefined, like this, undefined, and we don't need to check for this. And if we run this, this also works. As you can see, now tests are passing and everything works fine here. That being said, I would say that these kind of minor differences between the things that you are using in your interview session is really super important. And you might pay much more attention to them in case of how they work in general. And with that, hope you enjoyed this video and see you in the next one.